Okay, so it's been requested that I revisit inverse trig functions a little bit here. First of all, think about the fact that we have this idea that we have something called sine of theta. Of course, we could say y of sine of theta. We could say sine is, opposite over hypotenuse and all those various things. But the basic idea of we have a function. This is y as a function of theta. We could make that y as a function of x by making it this way, etc. And we've already talked about how to take derivatives of those types of things. So that's a type of function. But in addition, if we reverse this around and say, well, what if instead we started like this and we said, well, x is equal to sine of y, we could then say, in order to have an inverse function, we take the inverse sine of all of this, and the inverse sine of sine, since an inverse operating on itself, basically those two things cancel each other out, would just be y. And I could have a function, y equals sine of inverse x, where now y is a function of x again. It's now an inverse trig function, but it is still a function. And so since in these cases, we were able to come up with various, derivatives of sines and cosines and all those kinds of things, but we also can look at something like this and say, then we should be able to come up with derivatives of things like this. And so the inverse trig functions in general, that is what they are. Okay, now, worth talking about also that, if we think about the unit circle, we can say things like the sine of pi over 4, okay? The sine of pi over 4, we can say, what is that answer? Okay, the sine of pi over 4, and if we think about this is 0 on the unit circle, this is pi over 2. So pi over 4, of course, we've got all these various things, but that would be the one that is radical 2 over 2 would be both the y and the x there, so the cosine and the sine. So we would say, well, the sine of pi over 4 is radical 2 over 2. Conversely, if we're talking about the inverse trig function, we would say the inverse trig function of radical 2 over 2, and we want to know what that is. Well, that is asking the question, at what angle does sine equal radical 2 over 2? So just looking at this and looking at this, we say, well, when sine is radical 2 over 2, that happens at pi over 4. Or what is the inverse cosine of radical 3 over 2? And for that, we would have to say, okay, radical 3 over 2, well, what happens with cosines, the x value? So cosine is 1 down here. The next thing that happens is that cosine, this x direction, is radical 3 over 2. Again, thinking about the unit circle. And that occurs at the very first of these, which you can think of in terms of 30 degrees, 60 degrees, 90 degrees, or you can think of in terms of pi over 6, etc. So that occurs at pi over 6. And cosine of pi over 6, of course, would be radical 3 over 2. So that's kind of just the relationships that we have. And every one of these, sines and cosines and tangents and cotangents and all those, all have inverses as well. And whereas we could ask this type of question on a trig test, when we're talking about a trig test that involves inverse functions as well, we could ask these kinds of questions as well. Or what is the inverse tangent of, and we can put something in here like, for instance, radical 3 over 3. And radical 3 over 3, yeah. And we'd have to say, well, where is it that we can get radical 3 over 3 out of our inverse tangent? And so in order to figure that out, this is our unknown here, we say, well, we need a ratio. Where is there a ratio between sine and cosine that is radical 3 over 3? And that's what we would be looking for. So if you think about this, then where does that occur? Well, I think that 1/2 over radical 3 over 2, if my math serves me correctly here, the 2's would cancel. You'd have 1 over radical 3, which then you would multiply in order to get the radical out of the denominator. You would get radical 3 over 3. So this is saying, well, then that inverse tangent would occur wherever, and tangent is sine over cosine, so wherever sine is 1/2 and cosine is radical 3 over 2, which actually is the same thing right here, pi over 6, that we could figure out from that. And if there were negatives, that tells us it's somewhere else, you know, a different quadrant, whatever. Okay, so that's just inverse trig just in general, not having anything to do with calculus, but just having to do with inverse trig. And there's a few questions like that on the quiz. However, when we go to talk about it as it relates to calculus, a couple things that we want to point out. First of all, although we like to talk about the unit circle, not every case of a triangle that we have comes out as being the units, something on the unit circle, right? One of the special angles. There are certainly other cases where it just isn't. So we can have some angle theta here, and we could have y over here, and we could have x over here. And even just with that information, we could tell you, based on the Pythagorean theorem, if this is a right triangle, this would be x squared plus y squared. Now, if we're given one of these two sides, so say that we are given this triangle, and this is 4, then we would say, well, this side being x, that side being 4, would tell us that the tangent, or the hypotenuse side, would be square root of x squared plus 16. And we could, you know, if we had the other value, of course, if we had that this is going to be 5, then we could simply say, okay, then we square that, and we know what that's going, you know, we can do that, square root of 41, whatever. So they don't have to be things on the unit circle, but when we're talking about finding an inverse sine or an inverse cosine or whatever, we're usually wanting to look at one of those and say, well, what is the inverse sine of radical 2 over 2, something like that. So, if we're able to write down what these various sides are, of course, write them like this, then that means that we could also talk about the fact that, well, the sine of angle theta is what? This over this. But we could also talk about the inverse sine of this is theta, right? All those same things that I just talked about as far as inverse functions still applies. So having that theta by itself, you're taking the inverse sine of whatever's on the other side. Now, we could also have something like this. Let's say, we could say the tangent of inverse cosine of radical 3 over 2. Now, what's that really saying? Well, remember that this radical 3 over 2 in here, inverse cosine of that is going to give you an angle. So you're talking about the tangent of an angle, and we're okay with having tangent of an angle. Okay? If we see something like this, the best thing to do is say, okay, what are we talking about? We're talking about some angle. Theta equals cosine, inverse cosine of radical 3 over 2, which means cosine of this angle equals radical 3 over 2. And the best thing that we can do is to draw a triangle like I have up there. It doesn't matter if it's to scale or not. But I draw a triangle and say, what do I know about cosine? Cosine of this angle is the adjacent side over the hypotenuse. And if I have adjacent and the hypotenuse, I can get the other side by saying a squared plus b squared equals c squared. So c squared minus a squared is going to equal b squared. And c squared would be 4. And a squared would be 3. And that's 1. Take square root of 1, you get 1. And that means this side would be 1. Now, once I have figured out all the sides of that angle, and then I say, well, the question that's asked is this. What's the tangent of this thing? Well, once I've drawn this triangle, I don't worry about this thing anymore. That's where my triangle came from. And so instead I say, well, what's the tangent of this angle? Well, tangent of this angle, tangent is always just opposite over hypotenuse, or opposite over adjacent. Therefore, the inverse tangent there is going to be 1 over radical 3. And we can rationalize it. We get radical 3 over 3. But I can ask those kinds of questions, or I could ask, you know, what is the inverse, or what is the secant of inverse sine of radical 2 over 2? And again, what I really want to take out of this is, okay, first thing I want to do, I want to draw this triangle. I want to figure out what this triangle is. And so I look at this triangle and I say, okay, what does that mean? That is saying theta is equal to inverse sine radical 2, which means that the sine of theta is equal to radical 2 over 2. And of course, you can tell me what angle that is based on the unit circle, but also you can draw the triangle here and say, what does this mean? Well, it means that the opposite side over the hypotenuse is like that. And of course, my triangle is not drawn to scale because we know there's a 45, 45, 90 triangle. But then I could say on this side, well, again, a squared plus b squared equals c squared. Therefore, c squared minus b squared equals a squared. And this side being 2 squared is 4, minus radical 2 squared is 2. Take a square root of that, we get radical 2. And now, anything that I ask about this, secant, tangent, cotangent, whatever it might be, I'm asking about that triangle. So what is the secant? Secant's 1 over cosine. Cosine would be this over this. Therefore, 1 over cosine is this over this. And the inverse, there, the secant there, would be 2 over radical 2. And again, I can rationalize the denominator and get just radical 2. Okay, so that's, again, that's no calculus. That's just strictly based at that point on what we should know from a trig background there. Okay. Now, as far as calculus goes, we are interested in derivatives and integrals typically when we're talking about calculus. So, from a calculus perspective, I'm going to talk about this, and I'm going to say, okay, what if we say we've got this x, inverse sine of x is equal to y. And if I say that, well, then what am I saying? I'm saying I've got this thing that I want to be able to take a derivative of, and I'm not sure how to do it. So I look at this and I say, well, this is related to, if I was to take the sine of this whole thing, then I would have the sine of y is equal to x. Well, that's something I know how to deal with. How do I deal with taking a derivative of this? Well, the derivative with respect to x of this whole thing, derivative of sine is cosine. But I have to be careful here because it's not cosine of x, it's cosine of y. And since we don't know enough about y, we have to be able to say, okay, cosine of y times the derivative of y with respect to x. That's just chain rule. The derivative of x with respect to x is just 1. So then I look at this and I say, well, dy dx is equal to 1 over cosine. And 1 over cosine, well, that's also known as secant, right? But I also look at this and say, but I don't know what secant and y and all this kind of thing, I don't know what they mean because I haven't done yet what I did in those other ones where I was talking about an inverse. The first thing I should do here when I have this is I should say, I'm going to draw the triangle that is related to that. So when I look at this, what I am saying is, this is an angle. And what I'm interested in knowing about is what else is going on in that triangle. Well, when I look at this, which is the same thing, just written a different way, the sine of the angle is equal to x. Well, sine is opposite over hypotenuse. That means those two have to be those things. And again, from an a squared plus b squared equals c squared, or c squared minus b squared equals a squared perspective, this side is going to be 1 squared minus x squared. Of course, that's just 1 minus x squared. Now, I do that so that when I get to this point right here, I don't have to say secant of y, but I don't know what y is. I look at this and I say, I do know what the secant of y is. I don't know what y is, but I know that the secant of y, which is 1 over cosine, is the hypotenuse over the adjacent. Therefore, I don't just have to leave it here as a function of y, which is not what I want when I have dy dx. I want to know y as or the derivative as a function of x. Say, well, as a function of x, it is this over this. And so that's what I do with the derivative.